We are back, and our friend Dr. Bill Deese from Louisiana Tech joins us, our favorite chemist and mad professor, and we're going to do some kind of scientific experiment today. Nice to have you again.
Well, thanks a lot. It's good to be here.
The last time you were on, we put two chemical agents together, or elements together.
And we got a chemical reaction.
In a purple flame.
We had a chemical change occurred where we changed one substance, or actually two substances, into
a third substance.
Two or more entirely different substances. It had a different set of properties and even a different appearance.
Then we did a test on it.
That's right. And
that was fun.
So today what we're going to talk about is physical change.
You know, I have to make one point before we do this.
Okay.
Physical change, we'll come back to that. The colors you come up with are awfully pretty.
Well, you know, this is an amazing world we live in.
I mean, he's got good colors.
Easily entertained.
The man has really good colors.
Well, of course, we select bright colors when we're doing demonstrations, things like this. And of course, we want something to be visual that's on television.
Okay, now you said, let's back up. You said today we're going to demonstrate what?
Physical change.
Physical change.
And we have a physical change occurring right now. And what do you call that?
Water that's boiling.
It's boiling water. Okay, and
as it kind of looks like a still. It's got the
I borrowed that from an old moonshiner. No, I didn't.
Yeah.
But it does look like a still, and in fact,
I want to hold this back behind it because
can you see the
steam
coming out? Maybe not.
A lot of steam coming out that.
But anyway, we have a steam plume here. It's not showing up very well on camera. And but what we're actually doing, can you see the gas bubbles forming at the bottom of the flask? Okay,
yeah, sure.
And so liquid water is changing into gaseous water.
Isn't that redundant to say liquid water?
No. All matter has three phases: solid, liquid, and gas. Okay, and we're when we say water, we nearly always are talking about liquid water.
Right.
But ice is solid water.
That's true.
Okay, and when you melt ice into liquid water, that's a change.
Okay.
But the chemical makeup is still H2O. Solid water is H2O, liquid water is H2O, and gaseous water, which we have in our flask here, is H2O.
So that's actually a gas.
Right.
That's boiling around.
That's gaseous water. And by now, all of the air has been displaced in here by gaseous water, or water vapor, and it's coming through the copper tube, and it cools off a little bit, and we see this steam plume. Okay, now if you could see that, it looks a little bit like smoke, right? Or what we commonly call steam.
Yeah.
Do you think that's solid, liquid, or gas?
Gas.
That's what everyone says.
Liquid.
It's liquid, okay? Because gaseous water is invisible. Water in the vapor state is an invisible gas. Okay. So when you can see this, it's like a fog or like a cloud. That's actually tiny droplets of water, liquid water that we see.
Okay.
Okay. Now, do you know the temperature of this boiling water?
212.
212 degrees
Fahrenheit.
Fahrenheit.
Or 100 degrees centigrade.
Right, 100 degrees centigrade.
Okay.
Okay. And so now, as long as there's liquid water there, it's going to stay at 100 degrees. Okay. Now, by the time the gaseous water gets out here, it cools off a little bit, and you know I wouldn't want to hold my hand there very long; it would burn it.
But it's not 212 degrees.
Right.
But it's hot.
But you know it's too hot to hold there very long. But it's not dangerous to wave your hand through it. And if we put solid paper in front of that, all it's going to do is get wet. Okay.
Yeah.
And even a drop of water shot out there.
Right.
All right.
Okay.
But now what I'm going to do is light our torch here, and heat those coils up, and heat that.
Heat these coils.
Right, and heat up our steam plume here. Let's see. I don't like using this thing.
Hey.
Okay.
That just sounds like trouble.
Now, what is this?
This is just a little butane burner, okay? And it's giving me a little trouble, so maybe it'll cooperate.
Okay.
Now
we're heating the coil through which the steam is moving.
And it's going to heat up our steam.
Okay.
And as we heat that up, we should notice that our steam plume will disappear because
why is that?
The extra heat prevents the gaseous water from condensing in the liquid water. Okay. And of course, we're a lot closer.
It has disappeared.
Right. You can't see it anymore. So we have water vapor or gaseous water coming out of here. And it's above 100 degrees Celsius.
We've made a physical change in what was coming out of the tube.
We changed those tiny droplets of liquid into gas. And it's above 100, it's above the boiling point of water.
Now what if obviously if we put our hand
we don't want to put our hand in there now. Okay. This is superheated steam.
Okay.
And superheated steam can burn very severely, so you want to be careful. So let's put our paper in front of that and see what happes.
Ooh,
Yeah,
catches
I thought it
fire.
catch on fire.
Well, it doesn't burst into flame,
But
but
it
it
chars it.
definitely chars the paper.
Could it catch on fire?
Probably not. I've never been able to get paper to catch on fire,
Ooh,
but you can tell it's getting hot.
come terribly
But now
close.
what I have here is a match.
Can you hold this?
Sure, and hold it right. Be careful.
Okay.
Now, have you ever lit a match by sticking it in water?
Nope.
Okay, let's see if we can do that.
We lit a match by putting it in
Wow.
superheated steam.
Superheated steam, which was nothing more than water, but it was hot enough to ignite our match.
What's the ignition point of that match?
I
You know?
don't have any idea.
Ha!
Ha, we got the mad scientist.
Several hundred degrees Celsius.
It's about 240 degrees Celsius.
Well, 254 is the flash point no, it's 454 Fahrenheit is the flash point of paper. Remember the novel?
That's right, the
is
novel.
That 454 Fahrenheit?
454.
So that was probably around 400 or 500 degrees.
I just made that up.
That's interesting.
For the record, I want to know that was made
so
up.
we
You did
can
that well.
we can let things cool off now.
So we
and,
made a change in the physical property. Bill, it's nice to have you here today. Always learn a lot from you. Makes me want to go back to school and be a scientist.
Well, come on over to Louisiana
never too
Tech. We'll
late.
sign you up right away.
It's never too late.
Nice to have you here today. We're going to take a break. We'll be right back.